All right, let me snip this in. This is like the first question we did, but I'll work through it with you. That way, you've got a better understanding of how to do it.
Okay.
Snipping that in now. Let me share my screen. Here we go. Okay, so they vary inversely. That's very important. That tells you that's the equation y equals k over x. And they give you these numbers for x and y. So y is -1/6 and x is -12. So I mentioned this in the previous problem. You can cross multiply the butterfly, and maybe you saw that, but it's -1 times -12 equals 6k. 12 equals 6k, and that means that k equals 2. Now, the reason you need that is the first box, they want you to rewrite the equation. So it's y equals 2 over x. And that's what goes in that first box there. So you always find k, solve for k, then you rewrite the equation.
And then it's always going to be like 2 over x, or like
Well,
something over x.
like based on what I've seen, yes, but they could also give you the y value and ask you to find x,
Okay.
which we haven't seen yet, but maybe we'll see it in question 7.
Okay. Okay.
I try to tell you when I know for sure that there's going to be exceptions, but these computer generated problems, sometimes they are always the same.
Right. No, it's all good. But that one was right, so I'll share my screen back.
Great.
And would this be a direct variation because the 4 would be divided by?
Well, it's y equals kx, and k in this case is 4. So yes, it's direct variation. Perfect.
Cool. Okay.
Okay, so this time again, if you multiply the numbers, okay, 4 times 16, that's 64. 5 times 11, that's 55. Do you see how they're different?
Right, yeah.
Okay, so it's not inverse. Now, if we divide, like 16 divided by 4 is 4, but 11 divided by 5 is not 4. It's 2. Yeah. So this appears to be neither.
Nice. Oh my gosh. Oops. Okay.
Great. This one is like 1 and 6. I will snip it in.
And so since 7 doesn't have a what is it, denominator?
Yeah,
Would it be 1?
It would be 1. Yep. Okay. And so this one's a little bit harder because it's 5 over 3 is x. Mm-hmm. In the bottom here, it looks weird, but you still just cross multiply. Okay, so it's -7 times 5 over 3 equals k. And that on the left here, you just multiply the top, -35, and you multiply the bottom 3, and that equals k. So the equation is y equals k over x, and it would be -35 over 3 over x. This is correct, but it's like it doesn't look good. So the simplification here is to move the x up here and write it this way: -35 over 3x. It should accept this. It might have accepted the previous one, but this is the fully correct answer. And then for the next box, then part B here, you're putting 3 in for x.
So it'd be -35 over 9.
Perfect.
Okay. And then wouldn't this be like x equals 4y?
You'll go ahead and share your screen, please.
Oh, sorry. For some reason, I thought you could see it already.
I wish we could share them simultaneously. It would be a lot better, right? But they don't necessarily add that. Okay, this one remember it's y equals kx or y equals k divided by x. Do you see any multiplication or division?
No, so it'd be neither.
Well, it is neither, but yeah, I'm pretty sure it's going to want neither. Let's check it.
Yeah. So when it's adding and subtracting, it's neither.
Yeah. Because it actually has to go through the origin 0, 0, but you saw that one did not. Okay.
Right.
Why don't you try this one on your own? I will absolutely jump in if it and help if needed, but it is like the ones that we've been doing. You write y equals kx, and then you solve for k after you put those numbers in.
Okay, so it'd be like -4/1 equals 5/1, or k over 5.
K over 5, perfect, yep. So that gives you the value of what is -20, and then you rewrite that first line, that y equals k over x, as -20 over x. So go back to the previous line there. So that you've got to put an x in, write an equation. So it doesn't just want k, it's divided by x.
Like this over x.
Slash division. Nope. Why? I guess it's that one. Yeah, that's the right one.
Okay.
Whenever it's inversely, there's the fraction bar.
Okay. I get that. Right. I get that.
Okay.
For x, and then it'd be y equals -20/3. Okay.
Okay, let's look at the next one. So you've actually already answered this. It's neither, because there's an adding and subtracting.
Okay. And then
so try this one again on your own, please.
Okay. K equals 9.
K equals 9.
9 over k.
9 over x.
9 over x, I mean.
Yes.
And then it would be 3.
Yes.
And then this one would be division, so it'd be a direct.
Well, when you move that 8 over to the other side, it becomes y equals x divided by 8. But the k has to be a number multiplying x. So it is direct variation. It's direct variation because x is in the numerator.
Right. But if it was in the denominator, it wouldn't be.
That's right.
Okay.
Inverse.
Okay.
Okay, so this one is like the others we've been doing. Why don't you try this one on your own?
Okay. 24 over x.
Negative 24.
Negative. Oh yeah, there's negative 3.
K is negative 24, so negative 24 over x. And then when x is 3, what is y?
Negative 8.
Yes. Right.
Would this be neither? Or would it be an inverse?
You want to, I didn't do this in the last problem, but I'm going to share my screen. You really do want to you really want to solve for y. So let me share my screen real quick to answer this. When you solve for y, let me get this where you can see my screen. When you solve for y, you divide both sides by x. So it's y equals 1/5 divided by x. And I showed you earlier, like you can move it into the denominator. When x is in the denominator, this is inverse. But if it were like y equals 1/5 times x, this would be direct. So whenever the variable x is in the bottom, it's inverse variation.
Okay. So it would be an inverse.
Yes. Yes. Go ahead and share your screen whenever you're ready. And
Mm. Okay.
so this one you can do
14 over
for
x,
14 over x. Yep.
and it would be 7.
Well,
Oh, I'm just kidding. 14 over 3.
Perfect.
Would be a direct.
Where is x this time? Is it in the numerator or the denominator?
The denominator.
When it's in the bottom, the denominator, it's inverse.
Okay.
So the start by, if you've got a calculator, 12 times 132.
I'll just write these out because these are big numbers.
Yeah. Do you have or you can go to the Desmos Scientific to calculate them. But 12 times 132 is 1,584. And then 18 times 198, it's a much bigger number. So when they multiply x and y, when they multiply together, that's direct. But wait, hang on. Now we got to divide them. You got to do 132.
I already did divide them.
Okay. And did they not equal the same thing?
It was like 11 and 15.
Okay. Well, I'm looking at 198. Okay. Well, I'm looking at 198 divided by 18, and that's 11.
What?
Yeah. So, and then 253 divided by 23 is also 11.
No. I must. What did I do wrong? Okay, so it's direct variation.
Yes.
Okay.
We're gonna finish early, so just try to.
Yeah. No, I know.
Try to. Okay. I'm gonna snip this one in case you have questions. It does have a fraction, which is not the most pleasant. But your k is always x times y in these inverse variation problems. So when you multiply 3/4 times 28, you get 21.
Wait, what?
Let me share my
20
screen.
times 4?
Well, it's better to divide before you multiply. But let me share my screen so you can see this. So when you have y equals k over x, k is always x times y. And your x is 3/4 and your y is 28. And if you have a calculator, you just do this, but it's better to divide first. 28 divided by 4 is 7. 3 times 7 is 21. So that's your k. So it's 21 over x is your equation. But when x is 3, y is 7, because 21 divided by 3 obviously reduces to 7.
Okay. And that was the last of this one.
Okay.
And I'm thinking this is going to probably be, this is 7.2. I don't even have this one in my notes. I didn't go to school today, so I haven't learned this one.
Okay.
Yet.
Well, we'll see if it's easy enough to explain here. Share your screen whenever you're ready.
Okay.
All right. One of the nice things about identifying the graph is you can use Desmos to graph
I was just going to say. Okay.
Yeah. Now the rest of the stuff I'll have to help you answer, but let's go to Desmos and
plug in.
Yeah. Okay, so write y equals 10 divided by x, or 10/x. Okay. Now, go ahead and hit that home button there if you go back to Desmos on the right side, there's that house. If you could hit that.
The house.
Yes. So
Okay.
this is your default zoom. But notice your window, go back to your graphs. Do you see how your windows are? I'm sorry, go back to your the assignment player. Do you see how the graphs like the two on the right kind of look the same? Like it could be either the one on the right top, one on the right bottom. To figure out which one is correct, go back to the assignment player. You want to make the same window is one option, but yeah, it does look like it's that there.
Yeah.
Okay, so let's go down and let's look at these statements. So the graphs have the same asymptotes? An asymptote is where it's when you divide by 0, it creates an asymptote. These both have the asymptotes. So let's say they have the same asymptote.
Okay.
This will make more sense when we do more problems. So do they have the same domain and range? These actually do. Now go back to your graph, your Desmos, and in line 2, graph y equals 1 over x. Okay. Do you see how the green one is closer to the axis than the red one?
Yeah.
Okay, so let's go back to the assignment player. That's the next two questions. The graph of g lies closer to the graph of x. So g is the parent function. So it's actually g lies farther. Both graphs are in the first and third quadrants. That's true. The first is the top right.
Yeah,
And then you got
first, second, third, fourth, right?
it's counterclockwise. So the second is in the top left.
First, second, third, fourth.
Yes.
Okay.
Yes. So that's true, and that answers everything in that question, I think.
Cool. Yes.
All right.
Yay. Yay, another one.
Yep. So go to your Desmos, and you're going to graph this. Okay, so one thing you can do with Desmos is you can, I'm going to go back to it. If you hit the green there, left of the 1 over x, left of the, if you go to that green, I don't know, squiggly, no, don't delete it, type 1 there. Move your cursor over to where the green mark is. Go left, straight left, sorry. Go back to the 1 over x. If you click on it, it'll hide it and unhide it in case it's distracting. Okay, so go back to the assignment player, and let's see if we can find the one that matches. Looks like the one in the lower left there is correct. No, that's lower right.
My bad.
Lower left there. Like you visually see that those are the same now.
Yeah.
Okay. These have the same asymptotes. Okay. They have the same domain and range. But let's go now look at the next ones. So go back to your Desmos and uncheck or check on that. Do you see that the green one is closer to the axis? We'll talk about domain and range and asymptotes in a bit, but they're asking for a lot here. So it looks like G is farther from the graph. Looks like it's that second one. G is the one that's the -5 over x. It's the other one. Yeah. Okay. Now, are both graphs in the first and third quadrant? Oh, nope. That's the second one there. Yes. Sorry. They're not. You got it. Yes. No. Yes. Looks good now to me.
I was like, wait, what?
Yeah. I didn't need to say anything. You had it all down.
You're fine. Okay.
Okay, so this one is actually just like the previous problem. It's going to have the exact same answers. You probably are noticing that the negative moves the quadrants that it's in. But in terms of the of the comparison, they have the same asymptotes. They have the same domain and range.
It lies closer.
The G is the one you're graphing. So notice the green one is always closer. Yeah, that's further. These are written in that way. You have it as correct, and then it's literally like the same question as number 3.
Yeah.
So unfortunately, there's not a lot of like me showing you anything here quite yet. Maybe let's go to the, so if you want to make a mental note, this one is just like number 1. Exact same answers. But let's see if there's another, or if you want to do it now, that's fine.
I'll just put that in, but
yeah.
Go
ahead and choose your graph. It looks like it's that top right one. Oh, okay. Well, you're on number 5 now.
Wait, I'll just do this one.
Okay.
All right. Top right. And then same graph, same domain.
Can range, yeah. And then the next one is which one is closer. And the green one is always, it's always that second one for now. There will be an exception to that. This time they're both in the first and third quadrants. So you're just visually seeing that.
Cool. Okay, now I'll see if there's any other ones.
Okay, let's see if there's different ones, like you said. Okay, this one is different here. Okay. Scroll down. Let me see what the full question is. Okay, perfect. Okay. Go to your Desmos and graph y equals 2 over x minus 3. And then either uncheck that other one. Yeah. So do you, and then go to the third. Yeah, that go ahead and check that one more time. To me, yes. Okay, go back to your Desmos, please. Just want to show you one more thing. So if you go down on the third line, and type in y equals 3. I'm sorry, y equals minus 3, not 3, minus 3. Okay, now if you could just go to your graph and just zoom out just a tiny bit, do you see how that purple line is the horizontal asymptote? It's what it approaches. Can you visually see that?
Yeah.
So what that means is that that's a horizontal asymptote. So we're going to go back and answer some questions based on that, but I wanted you to see that. And the reason it's -3 is because of that -3 in the original equation. So go back to the assignment player and scroll down. Okay, so the domain is all the numbers except for what's called the vertical asymptote. Now, if you go back to the graph, the vertical asymptote is the vertical separator. Yeah, can you go back to Desmos? The vertical separator is at 0, x equals 0.
So it'll be x equals 0?
That's the excluded value. And if you go back to the equation up top, when you put 0 in for x, do you see that it's division by 0? 2 divided by 0, and you're not allowed to divide by 0. So the domain is those excluded values, okay? So we have to say everything but 0, all real numbers except 0. The range is all real numbers except for that horizontal line, which was at -3.
Cool.
Let's go see what 8 looks like, because I tried to do these where they're very similar. Let's see if 8 is like, no, can you go to 9? I'm hoping to get one just like that one we just did. Nope. Give me one more. See if it, no.
You can just go through all of them if you'd like.
Yeah, they're getting hard. Let's just go back to that one we left off at. And
which one did I do? Okay.
All right, so now let's go ahead and graph this one again in Desmos.
Okay. And then it's, but I just put 6 over
6, yeah, 6 divided by x minus 1. And then clear out that that last one there. Do you see that and go ahead and add one more line, line 4, and make this, or at line 3, and make it x equals 1. Do you see that both of those red lines, red curves approach the vertical red line? So that's your vertical asymptote. That's where you divide by 0. So when you're graphing these things by hand without Desmos, you have to like figure out where do you divide by 0, and it's at 1. So it looks like it's either that one, or it's because there's actually 3 that kind of look okay. So go back to your Desmos. Where does that graph cross the y-axis? Do you see, if you could just zoom out a little bit and click? Yeah, do you see where, up a little too far, but further down? So on that vertical axis, if you could just go to 0 and then maybe -6, down. Okay, let me left, 1 point left. Okay. Click right there. That's where it crosses the y-axis. Okay, so go back to your assignment player, and you want to find the graph that matches where that hits. So notice like the one on the right there. See how it crosses at that -6 point? Now you have it.
Cool.
Okay, so the domain, if you go back to scroll up just a tiny bit to that original function, where does the bottom equal 0? For what x value does the bottom equal 0?
The x.
What x value? Give me a number for x.
We could do 1.
1, yes, 1. So 1 minus 1 gives you 0. That's your excluded value. Great. Okay. Now, if you go, the range is all real numbers except it's if you go back to your Desmos. Do you see what the curve is approaching on the y-axis? Do you see how it looks like it approaches 0 if you zoom out? Yeah. So that's the excluded value. That's the one that it will help. It will approach.
Wait, so which one is it?
0.
0. Oh. Yeah.
So for the next one, I'm gonna snip in and give you a little more guidance on.
Okay.
So let me grab it here. All right, so let me share my screen. Then we'll get started here. Okay, sorry I didn't do this before. I thought maybe I could talk our way through it, but let's just talk about the domain and range real quick, because I think we're pretty comfortable with graphing it. For the domain, you set the bottom equal to 0. You set x plus 2 equal to 0. Okay. And then you solve for x. So x equals -2. This is the excluded value.
Okay.
Okay, so if you go on your screen, your domain is everything but -2. The range is a little bit different. This equation right here, y equals 1 over x plus 2, there's actually a plus 0 that's not written. This right here is called the vertical shift. And the range is everything but the vertical shift. So in this case, it excludes 0 because there is no vertical shift.
Right.
But let's say it was +5. Well, you would exclude 5 when you do this. Okay. Now, when you go to graph this, I'm going to just new share the wherever it went. Where did it go? There it is. When you graph this,
Let's see this.
okay, what I was trying to show you is that you can click on these places that it crosses,
Mhm.
and you can find the y-intercept, because that's usually a distinguishing point for which graph it is.
Right.
So I didn't get those. I didn't see those on yours, but I'll let you share your screen, and you can I can check if you would like the answer there.
But how do I get the all real numbers? It would be 0 for this one?
Which one? The range?
For the range,
Yes,
yeah.
the range, because there's nothing being added to the function.
Okay. Cool.
Okay, so let's do the domain and range first. Oh, you want to graph it first? That's fine.
Yeah. I'll just graph and I'll
Yep.
listen. Minus. Okay.
So let's match up the graph. So it's got to be in the second and the third quadrant. Looks good, or second and fourth. And then the domain, if you want to go down, it's all real numbers except where the bottom equals 0. So go back up to your equation. Where does x plus 2?
It'd be -2.
That's right. So your domain is everything except -2. Let's go back.
-2.
Yep. Go back to your assignment player.
And it'd be 0.
Yep. Because there's nothing being added to it.
Cool. And it'd be everything except for +7.
Yes.
And then domain would, range would be 0.
Everything except 0. Yes. I think it was x minus 7 in the bottom.
Okay. This one.
So why isn't it the one on the left there? Oh, wait, okay, never mind. You got it right. All right. Okay. So could you just go through the rest of the problems here just to see if they're like this or if there's a variation on it? Okay. These aren't that difficult, but they're just slight variation. One more. Oh boy. Okay. Well, yeah, we just need to do these. Okay. Yep. We'll just go back to the first one. That's remaining. I think we left on.
I think it was 11. Yeah. Or was it 10? No, it was 11.
11. Okay. When you see the equation, do you see that it's slightly different than what we did last time, the last few problems?
Yeah.
Okay. The graphing part you know how to do. So let's not do the graphing part now. Let's do the other part. The other part is the domain. You still set the bottom equal to 0. So where is 2x minus 6 equal 0?
It's going to be 2 times 3, and that would be a +6. So 6 minus 6 would be 0.
So when x is 3, the bottom is 0. That's your excluded point. Yeah. Okay. Now the range is slightly different. Let's go back up to the equation at the top. It's everything but the ratio of the numbers in front of x. So do you see how there's an 8 in front of x in the numerator and a 2 in front of x in the denominator? It would be 8 divided by 2, which is 4. So it's everything but 4.
4.
Okay, so if you're okay, I'd like you to check those, and then you can come back and do the graphing, but I want to make sure we get through as many as we can. So again, this time you set the bottom equal to 0. 4x plus 5 equal to 0 for the domain.
Okay. And it'd be like -5, so it'd be like 5 over 4.
-5 over 4. Yes. Okay, and then for the range, you do the same thing as I just said. You look at the numbers in front of x, so it's -5 divided by 4.
-5/4.
Yeah, it just so happens that they're the same.
That's funny. Okay, and then the like 1/3.
Yes, that's for the domain.
And then it'd be 2.
Yes, for the range.
Yes. Okay, and then +3.
That's right.
Over 1 and 1.
Yes, 1/1 is 1. That's that was a small exception, but yeah, it's perfect. Okay.
1 and then be -5.
Good. Okay, this one. Okay, so now we're back. Now we're back to the ones we were doing before. So the rules here are slightly different. The domain is where the bottom equals 0. So in this case, just 0. Right, because you're putting 0 in for x, it becomes 0. That's no good. When it's in this form, the range is that other number off to the right. No, the one off to the right. Let's go back up.
Was it 3?
It was 3, yeah. So there's two different types of problems that you'll see. This one's really nice because it's it's like this, and then the other one you have to do the other kind of set of operations. So let's go to the next question.
I believe this is the last one.
So this is back to that old type. So you set the bottom equal to 0.
8, 2.
2 for the excluded value in the domain.
And then do 1.
It's 1. I'll go back up to it's 1/4. Yeah.
Ooh. Okay. And now all I have to do is graph them.
I mean, if you'd like, we can I can help or suggest anything you would like for this. We still have some time left. It's totally up to you. But yeah, all you're left with is graphing at this point.
Yeah, I just put the equation in, right?
You put the equation in. Hopefully you see one that looks similar. And if you don't, if you're trying to choose between two of them, you can look for like a y-intercept. The hardest part's just gonna be remembering, what to go from one screen to the other. And me talking is probably a distraction.
No, it's fine.
Or x minus 8 on that. Yeah.
Yes. And then, oh yeah, I already got that one. And then x minus 1, x plus 5.
Looks good.
There's 3x. Yes.
So do you see how the curve is just to the right of the y-axis? There it is. There you got that. Okay.
Yes, I do.
Doing this much math, you should get an award. It is tough for most students to do in an hour.
Oh yeah, it's tougher to do it alone with like no help, and then like you're struggling there.
Yeah.
Like nothing, but yeah. But, plus 5. Okay.
Yeah, you got it. Okay.
X minus 6. That's a big space.
So I would zoom out on that graph a little more. That one does look correct, but I would hit the. I mean, you can check. It looks like you get a couple of answers, but if you zoom out, sometimes you get a little bit more visibility into which one is correct. That one looks pretty good though.
So that one, yeah, it is. Okay. Yeah. And then, all right, I'm all done then.
Okay, fantastic. Thanks so much for scheduling. I'll send you the notes here shortly, and I'll see you next time.
Awesome. Thank you so much. See you next time.
Have a great day. Bye now.